so Unit 5 starts out with just a little bit of a review. We're going to review simplifying radical expressions and square roots, first of all, before we start getting into some other stuff. So, first thing we're going to do is an example. We want to find the square root of 75. Now, is 75 considered a perfect square? No. So we can't take the square root of the entire thing. We can only take little bits of it, right?
Yeah.
So how do we know what we can take out that's a perfect square?
25.
5 and 25. What I do and what would be easier once we get to bigger numbers is we start taking the prime factorization. Okay, you guys remember the factor trees? 75. What are two factors of 75? 3 and 25. And we keep factoring until we get to all prime numbers. So 3 is a prime number, correct? But 25 is not. What are the factors of 25? 5 and 5. So let's rewrite the square root of 75 out of the prime factor. So that's going to be 3 times 5 times 5.
Oh, wait, what?
So we take each of the prime factors and we multiply them all out, put them inside.
Oh, all
okay.
right.
And then what gives us perfect squares? Pairs, right?
You bring that outside.
So we take it outside, and the square root of 25 would be 5 square root 3.
Wait, why did you bring it all the way back to the multiplying? You could have just shared it right there.
All right, so example 2, square root of 450. Right off the top of your head, do you know a perfect square that goes into that? No, so let's factor it out. Okay, so the prime factorization of 450. Just give me two factors of 450. There we go, 10 and 45. Okay, let's do 10 first. What are those factors? Good, 5 and 2. And what about 45? 9 and 5. But 9 is 3 and 3. So what do we have? I put them all in order from smallest to biggest, so it's going to be 2 times 3 times 3, 5 and 5. Okay, and then we take our pairs out. So we have 3s and we have 5s. So what's on the outside? Square root of 9 gives me 3 times 5, square root 2, and then let's multiply 3 times 5, 15 square root 2. Okay, now we have a number on the outside. Do you think that's going to affect anything, though? Not really. Let's factor out 24. Factors of 24, 6 and 4, 2 and 3, and 2 and 2. So let's rewrite it first. 7 root 2 times 2 times 2 times 3. And what pairs can we take out? There's a pair of 2. So that's going to come out to 7 times 2. Square root of 2 times 3? 6. And what's 7 times 2? 14 root 6. Okay, so let's start. Oh, let's do example 4.
Oh.
Okay, so now we have multiple things that we're worrying about. So let's first write out the prime factors of each of those, and then we'll do all of our multiplication. So 21, what are factors of 21? 3 and 7. And what about 35? 5 and 7. So the first thing I'm going to do is I'm just going to rewrite the whole thing. So 8 square root 3 times 7 times 2 square root 5 times 7. Okay? Now let's multiply it all out together. On the outside we're going to have 8 times 2. Inside the square root, we can multiply the insides, right? So let's just write out all of the factors first. 3 times 5 times 7 times 7. So what pair can I pull out there? I can pull out the 7s. So what am I going to have on the outside? 16 times 7, square root, 3 times 5, which is 15. What's 16 times 7?
112.
112. So 112 square root 15. That's our answer. Yep. This way, it's easier in this way to write out the prime factors, because then we can see it without having to do all that multiplication. Okay, so let's start with something maybe, still review. I can't remember if you guys do this in Algebra 1. Okay, now we're going to have a radical in the denominator, which we do not want. So we have to do what's called rationalize a denominator. Okay, so to rationalize the denominator, the first thing we do is we multiply the numerator and denominator by whatever's in the denominator. And you'll see what I mean in a second. And then we just simplify. So it's only 2 steps, but we need to make sure that we multiply both the numerator and the denominator. Okay, so let's look at example 5. Okay, so in example 5, we have square root of 9 over square root of 7. Now we have a square root in the denominator, which is something we do not want. So we're going to multiply the numerator and the denominator by that square root of 7. Now let's think about it really quick. Why am I multiplying by square root 7 over square root 7?
Get rid of the square root.
Well, what's square root 7 over square root 7?
1.
A 1. So if we're multiplying this guy by 1, are we really changing anything?
No.
No, which is why we can do it. Okay, and then we just multiply straight across. What's the square root of 7 times the square root of 7? Just 7. So it got rid of the square root in the denominator. Okay, and then what's square root of 9 times square root of 7? Square root of 63.
How come square root of 7 is so equal?
Because the square root of something is has really a exponent of, do you remember? 1/2. A square root is an exponent of 1/2. So if we multiply 7 to the 1/2 times 7 to the 1/2, that gives you 7 to the, what's 1/2 plus 1/2? 1. Okay? So that's why we can do it and why it works. Okay? So square root of 63, can we simplify that? Yeah. What are the factors of 63? 7 and 9. And what does 9 factor out to? 3 and 3. So this is the same as square root 3 times 7 all over 7. And we have a pair of 3's here, so we can pull it out. So we get 3 square root 7 over 7. And that's your answer. Okay? So a square root in the denominator is a big no-no. We don't want that. So we have to get this denominator to be an integer. Okay? So let's try. Okay, square root of 20 over the square root of 9. Now, we could do this, right, without having to multiply by the denominator, but let's do it anyway. So what am I going to multiply the denominator by? Or the top and the bottom? Square root of 9. Okay, so that gives me square root of 9 times square root of 9?
I have a question.
9.
Why can't you just...
Alright, and then what's square root of 20 times square root of 9?
180.
Square root of 180. Okay, can we simplify square root of 180?
10.
Yeah, 180. How about 18 and 10?
That's what I mean.
10 simplifies to 5 and 2. And what does 18 break down to? 9 and 2. And 9 is 3 and 3. Okay, so let's write them all out. So we have 2 times 2 times 3 times 3 times 5 all over 9. So we have two pairs we can pull out, right? 2's and 3's. So that's going to give me 2 times 3, square root 5, over 9. So that gives me 6 square root 5 over 9. And does 6 over 9 reduce at all? Yeah, 3 goes into 6 twice, and 3 goes into 9 3 times. So this is the same as 2 square root 5 all over 3. Now, could we have gotten to this point without doing all of this work? Yes. We could have, let me do it in a different color. We could have taken square root of 20 over square root of 9. Can we simplify square root of 20? Yeah, that's 4 times 5 over, what's the square root of 9? 3. What's the square root of 4? 2. 2 root 5 all over 3. Wasn't that easier? We could have done that first. I wanted to show you that it still works the long way. Okay? So we simplified the whole thing before we even started multiplying. The square root of 9 is 3. 20 can break down to 4 times 5. And what's the square root of 4?
2. Oh, okay.
You get the same answer if you simplify first. So now we're